Okay, today we're going to be learning lesson 2.5, creating and solving compound inequalities. The homework that goes with this lesson is off of pages 72 and 73, and we're going to do 4 through 22 even. So this intro gives a good description of what compound inequalities are. Basically, it's like compound sentences, how compound sentences put two sentences together and connect them with a conjunction like and or. It's kind of what we're dealing with here. When we have two inequalities that are considered at the same time, then we have a compound inequality. And the two inequalities are joined by the word and or by the word or. So we're going to look at an example of what an and situation would look like with inequalities and what an or situation would look like. So this first one outlined right here is a great example of an and situation. So in this problem it says Tina estimates that she can sell her old bicycle for at least $50, but she thinks the most someone will pay for it is $70. Write and graph a compound inequality to describe this situation. So in our case here, okay, this would be a situation where it would be very possible to have a number that is greater than or equal to 50, as well as be less than or equal to 70 at the same time. So some examples we could think of would be $60 would be greater than 50 and greater than 70 at the same time. So this would be considered an and situation because you could meet both of these requirements or conditions at one time. So if you look at what that would look like on a graph, if we graphed the inequality x is greater than or equal to 50, then we would start with 50 and say that that was everything to the right of 50. If we graphed x is less than or equal to 70, we would start at 70, and everything to the left of 70 would be less than or equal to 70. Well, if we want to meet both requirements, greater than 50 and less than 70, then this area in the middle where the two graphs would overlap would be our compound inequality that satisfies both conditions. So our graphs for and statements or and problems are always going to look like two dots with a line connecting in the middle, because those two dots will show what the least and greatest amount could be, and then the overlapping amount in the middle will be what is shown with the line that connects them. So this is how we would graph an and equality that is in between 50 and 70. But the correct way to write the inequality for this would not be to literally use the word and. We would place our variable x in the middle of our inequality. We would place our symbols always pointing to the left, and we would write 50, which is the smallest amount, to 70, which is the largest amount, and always write your and compound inequalities with this, kind of call it like an X sandwich. You sandwich the X in between the lowest and highest value that could satisfy both of these conditions. So this is my and inequality. Those signs will never point any other directions because what we have now is a statement that says X is less than or equal to 70, and then this says x is greater than or equal to 50, but we make them compound and join them together like this. So then when we take a look at what the alternate or situation would look like, this is the example we're given. Kiyoki will accept lawn mowing jobs that take him less than 1 hour or more than 4 hours. So if we were going to write this situation, there won't be an overlap like we saw with the bicycle problem up here, because there is no way that you can possibly have a number that meets the condition of being less than 1 and greater than 4 at the same time. You can be one or the other, but you can't meet both of them. So the appropriate word for this situation would be an or statement. And when it's one or the other, we can't join them together like this and make an and statement. You do literally use the word or in the middle of your answer. So or is the appropriate word to join these, and the graph is going to look quite different than this because since you can't be both of those things at the same time, your graph will not overlap. If I were to graph x is less than 1, it would be an open circle on 1 to show that it is not equal to 1, but it is anything less than 1. x is greater than 4 would have an open circle on 4 and go to the right anything greater than 4. So OR graphs will always look like this with two arrows pointing away from one another to indicate that the word OR means one condition must be satisfied. The single graph excludes certain numbers in the middle here, but includes the rest of the numbers. So now we've seen a decent example of and or. And we're going to take a look at what is going to be asked of us during this lesson. One of the easiest type of problems you're going to be asked to complete is you're going to be asked to write some compound inequalities from graphs. So you won't be drawing the graphs, you will be looking at a picture of a graph that's already completed and just simply writing what inequality would describe this situation. So I got these two graphs off of page 71 in the Your Turn problems. These graphs were already drawn out for us, and you're welcome to look at them on page 71 if you like. But it's numbers 9 and 10 up at the top of the page. And if this graph was drawn, the first thing I would ask myself is, based on what we learned from the front side of the notes here, if that looks like an and or an or graph. And since it joins in the middle, we're hoping that you would say that looks like an and graph. So to write the appropriate inequality for that, you would put your variable in the middle of the inequality. Because these are open circles, I know I don't want to put equal bars under my inequality symbols. They're simply going to be signs like this. And I can tell that this graph stretches between -8 and -3. And this right here would be my compound inequality that represents this and situation. But this one you can tell with arrows pointing away from one another that do not connect or overlap, that would mean an or situation. So all that needs to happen here is you're going to write what this inequality represents. On this side, we're showing that x is less than -4. On this side, we're showing that x is greater than or equal to 2. Because of the closed dot, we need the equal bar. And you put the word or in between so that this would be my compound inequality to represent this graph. And then we will reach a point where you will be given an and equation that needs to be solved, and you will need to solve for x and then graph the problem. So these are coming off of page 69, numbers 3 and 4. I've already copied them down, but you're welcome to look at them in the book as well. And in this situation, you're going to notice that you don't have x on the left or the right, you have x in the middle of your inequality, because our goal is to get x by itself in the middle so that our answer up here to number 9 that we just did, we want our final answer to look like this, with an x alone in the middle and a number on either side to show our compound inequality. So in this case, if we want to get x alone, what you notice in the middle is that there's a -3. You're going to do your same inverse operations that you always do with solving equations. So to get rid of -3, you would do the opposite and you would add 3. But the only difference is now you do it in the middle, you do the same thing on the left side, and you do the same thing on the right side. So you have to hit all the pieces of the inequality with the step that you are doing. And so that would leave us with 1. Bring down your less than sign. Keep the x in the middle. You have another less than sign. And this would be 8. So my final answer would be 1 is less than x is less than 8, which basically means x can be anywhere between 1 and 8. So to graph that, you would need to have a number line that stretches from at least 1 to 8. So I'm going to go ahead and start one number lower at 0 and number up through 8. Actually, I'm going to number through 9, just to make my number line a little bit longer than it has to be. And then I'm going to look to see if I want open or closed circles. There's no equal bar under these, so this is an open circle at 1, an open circle at 8, and the and statements always connect in the middle. Anything between 1 and 8 is a solution to this inequality. So we're going to try it one more time. This time, locate your x in the middle, and you're going to notice that in the middle you have two numbers to get rid of. We're going to need to get rid of the 3 and the 2 to isolate the x in the middle. So it's the same as regular equation solving steps. You would always undo the adding and subtracting before you ever did anything with the multiplying or dividing. So where it says +2, we're going to subtract 2 in the middle. We're going to subtract 2 on the left. We're going to subtract 2 on the right. So -10 minus 2 would be -12. Bring down your sign. you still have a 3x in the middle. This time this is less than or equal to, and then 8 minus 2 would be 6. And then we need to go ahead and complete it with one more step. We need to divide by 3 to get x alone. So if you do that in the middle, you must do it on the left and the right. So this will be negative 4 is less than x is less than or equal to 2. So this would be my final answer. And when we graph this one, what we want to be real careful about is that sometimes we may have a situation where one of the circles on my graph will be open and one of them will be closed. So pay attention to your symbols, whether they have the equal bar or not. And I'm going to start at negative 5 on my number line and just make sure I include everything from negative 4 up to 2. So I extended my number line to 3 there. And in this one I would have an open circle at 4, but I would have a closed circle to show that it could equal to, and then anything in between. So those are our and graphs that connect in the middle. So we're going to try a few with or. The or ones, you're just going to work each piece of this completely separate and write the word or in between your answers at the end. So this is a fairly simple one to solve. If I was going to solve for x, I would just add 5 on both sides of this inequality and get x is greater than or equal to 3. On this one, I would need to add 5 as well. So I would get x is less than or equal to negative 1. And then I need to make sure that I put the word or in between to show that this is a compound inequality. Graph-wise, we need to make sure we have everything from negative 1 to 3 covered on our number line. So I'm going to start at negative 2, count up from there. I went up to 4. And it doesn't matter which one of these you graph first, the graph will end up the same either way. So let's say I graph this first. X is greater than or equal to 3. So that needs to be a closed dot because it could be equal to 3, and greater than, as this arrow kind of shows, would be to the right of 3. And then I need to graph x is less than or equal to negative 1. So negative 1 is down here. Less than is going to point to the left. So if you ever get into a situation where you think you've solved correctly, but when you graph it, your or graphs are trying to overlap or point at each other or something like that, it's a good chance that you know you've made a mistake somewhere in your work that needs to be fixed, because or graphs should never point towards each other or overlap and connect. Okay, so let's try one more of the or statements. If I were going to solve this, first step would be add 1 to both sides. So we would have 4x is less than 16. I would divide by 4 to finish that and get x is less than 4 for this piece. And on this one, the only step I need to do to solve for x is divide by 8. So x is greater than or equal to 6. But I need that to actually look like a compound inequality, so I'm going to go ahead and write or x is greater than or equal to 6 down here by my 4 so that I have a complete answer. And this number line doesn't have to include very many numbers, it just has to stretch from 4 to 6. So I'm going to start at 3. I'll go up to 7. And then in this case, I need an open circle for my 4, and that would be less than to the left. I need a closed circle for my 6, and it's greater than, so it goes right. So the only thing left that we want to make sure we're ready to deal with is there are going to be a few word problems that ask you to just write an inequality and graph that represent the scenario in the word problem. So to do this, we need to take a look at a problem off of page 71. So on page 71, at the very bottom of the page, okay, there is problem number 12 down here that we're going to take a look at. And as you see, it says write a compound inequality to represent the indicated quality control level and graph the solutions. So it says the recommended alkalinity level for swimming pool water is between 80 and 120 parts per million inclusive. So when we talk about all those chemicals that go into a swimming pool, we've got to make sure we're keeping them at safe and acceptable levels, okay, for people to swim in. So this is one of the requirements that they've listed. The alkalinity needs to be between 80 and 120 parts per million. So you have to decide if this should be written as an and inequality or an or inequality. So the thing I guess you would ask yourself is, could numbers in between these two be part of the solution? Would it be acceptable for you to have an alkalinity level of 90 parts per million? And in this case, yes, that would absolutely be fine. So since you could have numbers between here, this would be an and situation. So the other thing I want to draw our attention to before I write it down on my paper is it does say inclusive at the end. What that lets you know is that the 80 and the 120 are included in the acceptable level. So when we write our inequality signs, we want to use the equal bar under them because it could be equal to 80 and 120 when we write this. So since we said this would be an and statement, we would put our variable in the middle. We're going to use equal bars under our symbols and say that the alkalinity level could be between 80 and 120 parts per million. So this would be my inequality, and then they would want me to graph this as well. So this would be a situation where you would definitely want to try to be logical and not count by ones on your number line because you're going to have a very long number line if you do that. So I would say maybe counting by tens would be a wise choice on this one. So I'm going to start at 70 and do 70, 80, 90, 100, 110, 120, 130. And I know that my levels could be equal to 80, equal to 120, or anything in between. So that is how we create, solve, and graph compound inequalities.